All right, ACT science. So, a study was conducted to examine whether female preferred to eat cat food, cheese, ham, or peanuts. So, we got 200 milligrams of the four foods, and figure 1 shows us how the mass of each food in the box change over time. So, uh, this is the mass of food remaining on the y-axis here, and then we have time going across the x-axis here. Okay. Let's see what figure 2 or table 1 shows the percent by mass of carbohydrates, lipids, etc. present in each of the foods tested. Okay, so we get percent by mass here. Okay, so let's check out the questions here. Figure 1, mass of cheese remaining at 4 hours is closest to. Okay, so on 4 hours here, and we want the mass of cheese, so that's the white. So I'd say 180, or so this would be 190. And this looks to be about 185. So C looks to be our answer here. So we go C. Okay. Suppose a company wants to use food as bait to capture this bee Germanica based on figure 1, which the 4 foods should the company place in the trap to maximize chance. So if the amount of food remaining is low, so let's say the mass of about that. So if the mass of food remaining is low, then that means that this the cockroach keeps coming back to it, and so we'd want something that would minimize the mass of food remaining. So you want something that would minimize the mass here. So so let's see. From the graph, we see that peanuts is consistently the lowest one with the mass of food remaining for each of the time slots. And so that is probably what we want here, because we want something that has a low amount of mass remaining for each time slot, which means that the cockroach keeps coming back to it. And so that would increase the chance that you'd be able to capture it. So that's number 2. So number 3, consider the 4 foods in order of percent by mass of proteins from lowest to highest. From food to food, as the percent mass of proteins increase, the mass of food remaining what? So this, we gotta go to table 1 first, and then we want proteins, right? So we want lowest to highest here. So that would be proteins. So you know, cat food would be the lowest, and then next lowest, third lowest, fourth lowest, or the highest here. So that would be how we rank it. So cat food, cheese, ham, peanuts. And we want the mass of proteins remaining at 28 hours. So let's see here. So it's from cat food to cheese to ham, peanuts. So it goes right down. So it looks like the mass of food remaining decreased only at time slot if we increase percent protein only. So go with B here. Okay. Consider this statement: the bee Germanica ate the food between 0 and 4 hours, between 4 and 16 hours, between 16 and 24, between 24 and 28. This statement is consistent with the data in figure 1 for how many of the 4 foods. So immediately we see that they started with 200 milligrams, but okay, so at the start, nothing has been eaten, and each time we decrease or we go across time, each one of them has been decreased. So black decreases, white decreases, gray decreases, stripes decreases as well for each of these time slots as we go down here. So this should be consistent with each time slot we have here. So the answer should be J, because um, in each of these time slots, the amount of food, mass of food remaining always decreases. So we go J. Student predicted that the bee Germanica would eat less cat food than ham by the end of the study. The data in Figure 1 support this prediction. So less cat food than ham at the end of the study. So cat food, so let's change color here. So cat food is blue, cat food against ham. So less cat food than ham. So this is false, right? Because, oh wait, no, this is true because um, this is less. So um, this distance is less than this distance here. And so this means that they've eaten less cat food than ham. So this statement is true. So let's see. So first of all, the answer is going to be yes, because it's true. The mass of cat food remaining was about 55 greater. So let's see. So we want this difference. So this is probably around, so maybe 175 minus 110. Whoa. 110. So this is about, why does this keep happening? So this is equal to about 65. It's just 65 here. So I guess 55 is good. We go with the A here. 95 is too great of a difference. So we want, in magenta here, we want this distance right here. Yeah, I want this distance. So the difference between these two lengths here. So that's 5. Based on table 1, when 200 milligrams of each of the 4 foods was placed in the box, water accounted for more than 100 milligrams of the mass of which of the box. So, table 1 here, water. And so what do we want? We want water accounted for more than 100 milligrams. So, and this looks to be percent by mass. So it looks like only one of them, or 2 of these actually, had percent by mass over 50%, which is 100 milligrams. So cat food and ham. So our answer should be G, because these were the only 2 foods where we had more than, so if you have more than 100 milligrams, that means that you have greater than 50% mass. So this implies this. And so we go G here. And that's the end of passage 1 of ACT Science.